Hello, good afternoon. How are you today? Welcome back to my channel, where we make things easy for you, Mr. J Mathematics and Logics. Today we are going to look at analytical geometry, solving problems when we have coordinates given. Analytical geometry deals with majorly three things. We'll deal with the length of size, calculating or figuring out the length of size, the gradients of a line, and also the midpoints of a line. So everything, almost everything we do around analytical geometry centers on this three. The gradient of the line, equation of a line, the midpoint of a line, and the length of any given line when we have coordinates. In other words, we call it also coordinate geometry. So how do you know that you're supposed to use this method? You know when the coordinates are given. Let's quickly go through this question. For the given sketch not drawn to scale, it may not appear the way we want it, but they are asking us to figure out the length of the radius if AE. It means that this line is actually the diameter of the circle. If AE is the diameter of the circle, we should figure out the length. Now, distance formula says that AE, for us to get AE, it has to be the square root of x2 minus x1 plus y2 minus y1 of any given coordinate. We have two coordinates. We are looking at E, which is -7 and 15, and we are also looking at A, which is 3 and -9. So we can call this our x1 and call this our y1, x2 and y2. So we plug into the equation. So we have square root of 3 minus 7 is 3 plus 7, that is 10 all squared. Plus -9 minus 15 is -24 all squared. -9 minus 15 is -24 all squared. So this is what we are going to use to get the length of AE. Therefore, our AE is going to be square root of 100. And let's look at 24. Square root of 100, and we have 24 times 24 will give us 576. So we are looking at square root of 676 as the length of AE. So we look at 676. The root is 26. So AE is 26 units. AE is 26 units. But they want the length of the radius. AE given is the diameter, not the radius. Remember that the diameter is equals to radius to radius. So radius will be diameter divided by 2. So the radius for the circle will be 26 divided by 2, which is 30 units. So that is what we have here. Now, they are asking us to get the value of V. If V, the coordinate of V, if V is the diameter of that circle. If V is the midpoint of that circle. Now, if V is the midpoint of this circle, we can use the midpoint theory to get our V. So in a nutshell, we are looking at V being the midpoint of A and E. V being the midpoint of A and E. Midpoint formula is slightly different. So for midpoint, we have x2 plus x1 all over 2 will give us our x coordinate. Y2 plus y1 all over 2 will give us our y coordinate for the two given coordinates that we are working with. So here we have 3 plus -7. 3 minus 7 is -4 over 2. And here we have negative 9 plus 15, and that is 6 over 2. So the coordinates of AE will give us negative 2 and 3, and that is the coordinates of V, which is the midpoint of that. Remember, we can also use a different method, but this works fast because the midpoint of a diameter divides the radius into 2 equal parts, and the midpoint, which is the coordinate, is negative 2 and 3. Now, the next question is asking us to figure out the equation of line SA. Equation of line SA. This is line SA. It is a straight line graph. The equation of a straight line graph can only be gotten with this formula, where M represents gradient and C represents the y-intercept. In this case, we don't have the y-intercept, so but we can actually get the gradient. The gradient of SA is y2. Remember, y2 is changing y over changing x. So y2 here is, I have negative 9 minus y1, which is 3 between s and a. And then for the denominator, I have 3 minus 15. And this will give me negative 12 over 18, which will give us negative 2 over 3. That is our gradient. Negative 2 over 3 is our gradient. Now let's look at this. Going forward, if that is our gradient, we can use this formula. We plug in negative 2 over 3x plus c. Now we choose any of the coordinates on the line and sub in to get our c. We sub in negative 9. If we are using this, we sub in negative 9 for y, and we sub in 3 for x. That will give us our c. This will cancel like this. Negative 9 plus 2 gives me negative 7. So c is negative 7. So the equation of SA will give me negative 2 over 3x minus 7. If we look at it, it's a negative graph, and the y-intercept will be on the negative part. So that is the equation. Remember, to get the equation, use the 2 coordinates given to get your gradient. Then with your gradient, use any of the coordinates, sub into the equation of a straight line graph to get your c. And then that gives you the equation of the given line SA. And now let's look at the last part of this. The last part, they want us to figure out if SE is perpendicular to SA. SE is perpendicular to SA. For perpendicular lines under analytical geometry, the gradient of SE multiply the gradient of SA must give us negative 1. Please remember, for parallel lines, we have the gradient of 2 lines being equal. Will give us, so if we have AB and CD being equal, then it means that AB is parallel to CD. If we have gradient of AB times gradient of CD, their product giving us negative 1, then we know that AB is perpendicular to CD. So this is what we are going to look out for going forward. Now we need to get gradient of SE and get gradient of SA. If they are perpendicular, when we multiply them, it will give us a negative 1. Now let's go. SE, gradient of SE will be changing y over changing x. So we have 15 minus 3 is 12 over negative 7 minus 15. Negative 7 plus 15 will give us 8. So we have this will give us, if we divide with 4, we have 3 over 2. Let's look at gradient of SA. SA is here. changing y over changing x, -9, -3 gives us -12. 3 minus 15, that's 3 plus 15 is 18. So if we simplify this, 6 is a factor, we will have -2/3. Now let's multiply it. 3/2 times -2/3. This 3 will go, that gives us a -1. Therefore, we can comfortably say that SE is perpendicular to SA because the product of the ingredient equals to -1. So this is how we work around. Remember, we've done a lot here. We've used the gradient formula, we've used the midpoint formula, we've used also the distance formula, as well as establishing the equation of a straight line graph. So these are all we do. This is like one equation that compresses everything. It compresses everything in one. So with this, we can touch every aspect of analytical geometry. Please remember, if there's any particular part that you're struggling with, remember to pop that question, ask us. We are here to help you. I'll see you in this video. Keep on sharing the video and keep on encouraging your friends to subscribe. Please do not just watch, share, follow my pages, subscribe to my channel. God bless you.